So, how did we know the Earth was round? I mean, way before we had rockets and pictures from space. It's a fascinating question, right? And the answer was actually figured out thousands of years ago, just using some brilliant observation and a little bit of logic. We're going to walk through the clues, one by one.
And really, it all kicks off with something super simple. You just look up. You look up at the sky, and what do you see? Spheres. Everywhere. The sun is a sphere. The moon is a sphere. All the planets we can see, they're all round. Which leads to this great point from Neil deGrasse Tyson. He basically asks, why would Earth be the one weird, flat exception in a universe of round things? It just doesn't add up. And that's the puzzle we're going to tackle today.
All right, so let's dive in. Our very first clue, believe it or not, doesn't actually come from looking up at the stars. Nope, it comes from looking at the fundamental rules that run the entire universe, the laws of physics. Okay, so here's the deal. It turns out that a sphere is basically the laziest shape in the universe. Seriously. For any big, massive object that's being pulled together by its own gravity, a sphere is the most energy-efficient way to exist. Nature always finds the path of least resistance, and for a planet, that path leads to a sphere. It's like the universe's default setting for big stuff.
And this also explains why some planets aren't perfect spheres, right? If you've got an object that's spinning super fast, it's going to start to bulge out a little at its middle, at the equator. It gets a bit squashed. But see, that's just another force, rotation, messing with things. The main rule, the fundamental one, doesn't change. Gravity, left to its own devices, always goes for the sphere.
Okay, let's get to our first big piece of observable evidence. This is a clue that's so simple, so elegant, that the ancient Greeks figured it out thousands of years ago. It's pretty amazing.
And this whole clue hinges on a cosmic event you've probably even seen yourself, a lunar eclipse. So what is really going on up there when the moon seems to go dark or turn red?
It's actually a really simple process when you break it down. Step 1. The sun is always on, right? And it's always shining on the Earth. That means the Earth is constantly casting this massive shadow out into space. Step 2. The moon orbits us, and every so often, it passes right through that shadow. And when it does, this is the cool part. We get to see the shape of our own planet projected onto the moon's surface. So what's the shape? Every single time. It's a perfect curved arc.
And this is the absolute key. You might think, well, a flat disk could make a circle shadow, and yeah, it could, but only if you have it lined up perfectly with the light source. Tilt that disk just a little bit, and the shadow instantly becomes an oval or even just a line. The only, and I mean only, shape that casts a perfectly circular shadow every single time, no matter which way you turn it, is a sphere. For the ancient Greeks, this was checkmate. Game over. The proof was right there in the sky.
All right, clue number 2. This one is something that anyone who's ever lived by the sea would have noticed for thousands of years. It's as simple as watching a ship sail off into the distance.
Now, just imagine for a second. If the Earth were a giant, flat plane, a ship sailing away from you would just get smaller and smaller and smaller until it was just a dot you couldn't see anymore. But that is not what happens. What we actually see is the bottom of the ship, the hull, disappear first. Then the main deck, and the very last thing you see is the top of the mast. It literally looks like the ship is sinking below the horizon.
So that begs the question, right? What kind of surface would make something disappear from the bottom up? There's only one answer: a curved surface. The ship isn't sinking, of course. It's just following the curvature of the Earth as it sails over the horizon.
Okay, so seeing shadows on the moon and ships disappearing, that's pretty convincing evidence. But the real aha moment, the giant leap for human intellect, was when one person not only proved the Earth was round, but he actually measured it. And he did it with shocking accuracy.
And here's a little mind-blowing fact for you. You know the math he used? Geometry. Well, the word geometry literally comes from the Greek for earth measurement. How cool is that? Its original purpose was baked right into its name.
So let's talk about this genius, Eratosthenes. How in the world did he pull this off? No satellites, no telescopes. He just used 2 wells. That's it. 2 wells in 2 different cities, hundreds of miles apart. Sounds like a riddle, doesn't it? How can 2 wells possibly prove the Earth is curved?
So the whole thing started with this one key observation. Eratosthenes heard that in a city to the south, Cyan, on one specific day of the year, the summer solstice, the midday sun shone straight down to the bottom of a deep well. No shadows. But at that exact same time up north in his city, Alexandria, a stick in the ground cast a very obvious shadow. The sun wasn't directly overhead there.
And this is where it gets really, really clever. Because with just those two pieces of information, a shadow here, no shadow there, you actually have two competing theories. Theory 1, the Earth is flat and the sun is small and close by, which would cause its light to hit at different angles. Plausible. Theory 2, the Earth is a sphere and the sun is huge and far away, so its light rays are essentially parallel when they hit us. Both models perfectly explain what he saw. So, how do you figure out which one is right?
Well, you do what any good scientist or detective does. You get more evidence. You add another data point. Just imagine if you had a third, in a third city, even farther away. That one extra piece of information. It changes everything.
And this right here is the scientific method in all its glory. You can kind of fudge the numbers and make the flat Earth model work for two wells. But it absolutely falls apart when you add a third. The angles of the shadows just don't make any sense. The only model that perfectly explains the shadow length in all three places is the one with a round Earth and a far-off sun. The evidence just becomes slam dunk, undeniable.
So that brings us to a really interesting question. If we figured this out over 2,000 years ago, and today we have mountains of evidence, GPS, air travel, actual photos from space, why are we even talking about this? Why does this myth persist? Well, Neil deGrasse Tyson has a thought on this, and he boils it down to two main things. First, we live in a country that fiercely protects free speech, which is a good thing. It means you can say whatever you believe. But second, and this is the more critical part, he suggests it points to a pretty serious failure in our education system.
And it's not really about just memorizing facts like the Earth is round. It's about something much deeper. It's about learning how to think critically. It's about knowing how to look at evidence, how to test an idea, and how to tell when a theory just doesn't match reality. The point of education shouldn't just be to fill our heads with what to know, it should be to give us the tools to understand how we know it. You know, when you look at the whole story, discovering our planet's shape is really just this beautiful testament to human curiosity. It's a powerful reminder that with nothing more than our own eyes, some smart questions, and a little critical thinking, we can figure out the deepest truths of the universe. The tools might be simple, but the results, well, they can literally change how we see the world. So, yeah, the takeaway? Keep asking questions, and always, always keep looking up.